guys, I'm Jubeloria and I'm here to answer all the activities in Chapter 7. Chapter 7, IP Addressing. Addressing is a critical function of network layer protocols. Addressing enables data communication between hosts. With computer networks, an address refers to an IP address or other unique network identification. On the internet, an address is a synonym for a web address. An example of web address is the computer. So this chapter examine in detail structure of IP addresses, their application to the construction and testing of IP network and subnetwork. So let's answer the activity in chapter 7. The first activity in chapter 7 is binary to decimal conversion activity. So the instruction, this activity allows you to practice 8-bit binary to decimal conversion as much as necessary. We recommend that you work with this tool until you are able to do the conversion without error. Convert the binary number shown in the octet to its decimal value. So this is the decimal value. This is our base and the exponent, the position, and the bit. So in this activity, we need to convert the bit into decimal. So in the bit, the first number of the bit is 1, 2, 4, 8, 16, 32, 64, 108. So we need to add all the bit 1 except the 0. So if we add 4 and 128, the answer is 132 because 128 plus 8 plus 4 is equals 132. So let's check if it's correct. So the decimal value you have entered is correct. Please click new number to continue. So the answer 132 is correct because if you add 128 plus 4 equals 132. So the next activity in chapter 7 is decimal to binary conversion. So the decimal to binary conversion activity is this activity allows you to practice decimal conversion to 8-bit binary values. We recommend that you work with this tool until you are able to do the conversion without error. Convert the decimal number shown in the decimal value row to its binary bits. So 132 is our decimal value. This is our base and this is the exponent and the position. 1, 2, 4, 8, 16, 32, 64, 128. So the decimal value 132 we need to convert into bit. So if we convert the 132 to bit, answer is 1 0 0 0 1 0 0. So let's check if correct. Correct. The binary values you have entered for your position are correct. Please click new number to continue. So the 132, when we convert into the bit, is 10000100, because 128 plus 4 equals 132. All of the binary one we need to add to get the decimal value. So the next activity is the activity unicast, broadcast, or multicast. When we say unicast, the destination of the unicast are one, the multicast are two or more, and the broadcast are all the PC that we see. Instruction: click Start to view the destination IP address. Next, click the host, which will receive a packet based on the address type: unicast, broadcast, or multicast. This is a time activity. So this is the IP address. This one is the our source host. The IP address PC. So in this activity, we need to identify which IP address is will receive the correct packet base addresses type. So we need to type. So 192. So this is unicast. You have successfully identified the transmission type. So try again. Set, please start. So this is unicast again. You have successfully identified the transmission type. So this is unicast again. This is type of unicast. You have successfully identified the transmission type. This is multicast. You have successfully identified the transmission type. So the next activity is activity pass or block IPv4 address. Decide to pass or block each IP address depending on whether it's public, the internet, or private small local network. Click Start to begin. Click on either pass or block. So in this activity, we need to pass or block all the IP address we see and monitor. So let's start. So pass, pass, pass. So pass. So pass. So we got 10 points. You have successfully identified public and private IP address. So we successfully identified which IP address when it's private or public. So the next activity in this chapter is activity public or private IP address. When we say public or IP address, the public and private address, a private IP address is an IP address that reserves for internal use behind, or a root or other network address. Translation: device apart from the public. Private IP address are in contrast to public IP address, which are the public and cannot be used within a home or business network. So the public IP address is cannot be used with a home or business. The IP address is reserved for internal use behind a route or other network. So we need to identify all the IP address when it's public or private. So the 172.16.35.2, I think it is a private, and the 192.168.3.5 is private again. The 192.0.3.15 is public. The 64.104.0.22 is public again. The 209.165.201.30 is public, and the 192.168.11.5 is private, and the 172.16.30.30 is private, and the 10.55.3.168 is private again. So this these are the IP address in public, and these are the IP address in private. So let's check if the IP addresses are correct to this category, the public and private. So you have correctly identified all the IP addresses. So we identified the IP addresses whether it's public or private. So the next activity is the activity IPv4 issue and solution. Instruction: drag the IPv4 and IPv6 term to the field next to the appropriate description. So these are our choices and the description. So we need to drag all term to the correspond description. So 128-bit addresses, 340 undecillion addresses. So I think it is IPv6, and 32-bit addresses, 4.3 billion addresses, I think it is IPv4, and transport an IPv4 6 packet over IPv4 networks. I think it's tunneling, and uses NAT64 to convert between IPv6 and IPv4. I think it is translation, and allows IPv4 and IPv6 to coexist exist on the same network segment is dual stack. Mhm. When we say IPv6, Internet Protocol version 6 is most recent version of the Internet Protocol, the communications and location system for computers on networks and routes traffic across the internet. And when we say IPv4 or Internet Protocol version 4 is the fourth versions of the Internet Protocol. It is one of the core protocols of standards based internet working methods in the internet and other packet switch networks. When we say tunneling is a protocol that allows for the secure movement of data from one network to another. Tunneling involves allowing private network communications to be sent across a public network. So the translation is uses NAT to convert between IPv6 and IPv4. They convert IPv6 and IPv4. The dual stack means that devices are able to run IPv4 and IPv6 in parallel. It allows hosts to simultaneously reach IPv4 and IPv6 content. So let's check if the term are correct in their description. So you have successfully matched the IPv4 and IPv6 terms to their description. So next is the activity practicing IPv6 address presentations. Instruction: convert the IP addresses into short, the leading zero, and compress forms used to the number at the bottom of the page to continue this activity. So the IPv6 conversion, the preferred format, this is this are the preferred format, the omit leading zeros, and the compressed format. So we need to identify all the omit leading zeros. So the omit leading zeros is 2001. Next is 0, only 1. Next is DB8. So we need to copy the DB8 except the 0 and the 1111 and the 0, 1, only 1, and the 0, only 1 again, and only 1. So we need to copy to 0, 0 except the 0. So compress format, we need to compress all these omit leading zeros in format. So 2000 0 D B 8 1 1 1 1. So we don't have to need copy the three zeros. We need to copy only the 200. So check. So congratulations, you got them all. So we got the IPv6 conversion, the correspond omit leading zeros, and the compressed format. So the next activity in chapter 7 is the activity identifies types of IP addresses. Instruction: drag the IP addresses type to the most appropriate description. So in this activity, we need again to drag the IPv6 address to the most appropriate description. This is the description and these are the term. So the unique internet routable IPv6 addresses, dynamic or static. I think it's global unicast. The FE80 one is I think link local. The 2001 DB8 ACAD1 slash 64 I think is global unicast. The typical IPv6 prefix used to identify the network portion of the address, I think it's slash 64, and used to communicate with other devices on the same IPv6 subnet is I think local network. When we say global unicast in Internet Protocol version 6 IPv6, a conventional publicly routable address that can be used in the Internet or any public domain that is associated with a single node and can in effect identify the node. When we say link local, in a computer network, a link local address is a network address that is valid for communication with the network segment or the broadcast domain that the host is connected to. So let's check if the all the terms that we drag are correspond or correct to their description. So you have successfully matched the IPv6 address type to their descriptions. So that's all guys. I hope you learned from those activities I've answered in chapter 7.